future, like so even in parallel I'm preparing some the YouTube videos and all, so that so once I publish the YouTube videos, probably you can go and see that, or else in online we have so many dimension reduction related things. But what I will do, like a customized version to understanding a reachable version of the dimension reductions, I'm working on that, and I'll prepare the video as well. Okay, so that you can go ahead and feature. So probably, so in this WhatsApp group I can share, or else I can share with your ma'am, so you can just go ahead on that. Okay, so the dimension reduction is nothing but, say for example, let me take my any sample of Excel sheets. 1 minute, I can boot that my that this one. Okay, Excel. Yeah, yeah, paint. Okay, so why we need that dimensional reduction basically? So I'll give the nice examples. If see now, actually so far we discussed with a few um, linear regression, logistic regression, and random forest and decision tree algorithm. So we have used the few other algorithms we are implemented, right? But the most of the times actually we have used a very few column, and sometime I think hope you remember we have used um, this one, right? The linear logistics regression. We have used a Titanic data set, and we have analyzed like the predicting like whether alive or not. Those informations we have used a simple Excel sheet. Okay, so that is actually for training purpose we are using that. But in real time, certainly this Excel sheet not going to be like only a 10 rows or 20 rows, something like that. So there are the chances there might be 100 columns, or lakhs of rows might be there. So in that condition, what we will do? So we have to like take care of we have to take care of the all the column for our analysis. So how we can do that? And same time, we might have to verify that then the how many columns we want, and how we can do that in very effectively without reducing the futures. Okay, so this is, let us say for example, I'm preparing this small um, what is that? This is considered as Excel sheet, and I might have the column. This is going to be a column one, okay, and this is going to be a column two, and so on. Here, let's say this is column 40, and this is might be sometime column 50. Almost like in between, I have so many columns. Okay, let us assume in that way. Okay, so here, something like that. Okay, I have n number of columns over here. So if I'm doing this kind of the huge column size, the analysis of this kind of like either it could be linear or regression or supervised, unsupervised, and random forest, whatever it is, the column size is more and more. So how I can do that? So for this and all, basically we supposed to use the concept called um, dimensional reduction. The dimensional reduction is simply a process of reducing the dimensions of your future set. Future set is nothing but your column. Already I mentioned that, right? So future set. Your future set could be a data set with the 100 columns. So that's what I mentioned in my example. Just I'm giving a 50 column means. So what I can do, I can split up this one in different dimension, kind of XYZ. Okay, it's a huge topic. Anyway, just to try to understand the dimension reduction for your level, guys. Like to try to understand the dimension reduction is simply the process of reducing the dimensions of the future set. So what we can do, if we have a 50 columns, by applying, we have a different scenario. So don't confuse with the other things. The major one, principal component analysis. So PCA is nothing but here we need to have all the columns supposed to be a features, the numerical features. So what we used to do, you know that very well, right? Category variable we want to convert into numeric variable, automatically we'll get that. So we had one challenge when we are doing some small project. So there was a category variable for a specific column, but the number of the number of options might be more than 100. So what will happen if you're converting that the categorical variable into numerical variable? What will happen? It's become additional 100 column piled up with my existing data set. Hope you can remember, right? So initially, if I have just only until this one, okay, but after this is my the basic data table, okay. So if I making like it's going to be a what is that, category variable into numerical variable by using a dummy variable or encoding variable, hard coding variable, all other features, if I put that, what will happen, the column size going to be increased phenomenally, so that I'm not able to handle the situation. Because just for some other option, let's say like if you take a number of subject in your engineering, right? It might be like initially it's going to be a number of subject here, okay. Here the subject, the list, okay. Here going to be a subject, name of the subject. So what will happen if I have the first semester to your eighth semester, it could be almost I can remember almost 58 or 54, something like that. I'm not sure about that. Sorry about that numbers. So it comes around 44, 54 subject means. So I want to make all the subject as into the categorical variable. What will happen into numeric variable? The 54 subject going to be the column width, correct? So all the subject become separate column, and each column it has like the name of that subject, and here going to be a zero or one combination. So initially the student name and registration number and their sex detail and their date of birth and their address, and it could be um, okay, that is enough for this, and it could be a branch, okay. And even if it is branch, if I'm converting into that the numerical variable, what will happen, if in your college you might have a 5 or 6 branches. So additionally, how many column will be generated if you are converting into categorical variable into numerical variable? So if initially is going to be a one row for that one, but if you're converting into the category variable for department itself, it's going to be 5 columns, okay. And 54 initially the subject is going to be a one column, let us assumption, okay. Make it as like a simple, so 54 column. So and again it's going to be what, how many columns? So each and every department means it's going beyond that more than 100, because if I'm including mechanical, electrical, electronics and communication, or production engineering means, so individual subject might be different. So the 54 going to be more than 100 or 150 subject might be across all engineering streams. So what will happen, my the overall uh, the column, total column going to be more than 200 columns. So believe me, so how you can do all the analysis, how you can do the analysis, so using the 200 column. So in that concepts, by the time applying that PC analysis, there is nothing but principal component analysis. So we can apply some certain rules on it, and we can work on that. We can predict that analysis, and we can do any classification model or any regression model. We can do that. That is nothing but is a mainly for dimension reduction techniques. So there might be we can have like the random forest method. Actually, feature selection in the dimensional reduction techniques, we have a major thing: future selection and dimensional reduction. The dimensional reduction, we have so many options are available, but that's like it's a really very high level. But for you guys, like slowly you can try to understand the concept, because overfit for you guys. And in future selection, already we have concluded with this random forest. Random forest is nothing but what, collection of decision tree. So you want a decision tree means you need to go ahead for applying the decision tree algorithm and finding that entropy gain. And we have one more thing like gain and the Gini. We have the another Gini. That's what's not included that. So if you're applying all those concept in that, you can identify that the decision tree thing, and followed by a random tree if you applied. And the same way we want to select the future selection. Future selection we have the one more thing: backward future selection, forward future selection. That is very simple concept. The concept will I explain you guys so that you can understand that what they will do basically. Let me open my Excel. I don't know this is working or not. Like on me should be your yeah, cool. I'll use my auto. This is simple. The name itself, like the conceptual, is just try to understand. Okay. So what I will do, this is my table. This is my, this is my data set. Already we have discussed this many time. Okay. So what I will do, future select backwards future selection is nothing but as I mentioned earlier, like I think you remember, right? Yesterday, actually, we did decision tree analysis. Yeah, selecting the few column, the selected column in my analysis, I'm getting some set of different accuracy. And same time, if you want to improve that, probably you can reduce the number of the features for your as your different variable. For example, as I mentioned earlier, let me make it as in normal color so that it will be easy. Acha? Right. Cool. So if I want to find out, this is my target variable and these are my independent variable. Okay, including the name. For example, include the name instead of that. If you have any location, consider this as a location or any other category variable. So initially, what I will do, I am going to select all this. How many columns are there? How many columns is going to be? Yeah, 8 columns. Here I have 8 columns. So 8 columns, 8 features going to be a independent variable, and one this is going to be a dependent variable. So if you are finding that the accuracy might be different, and again what I'm doing, I'm leaving this one. I'm selecting the next 7 columns, first 7 columns, and I'm doing my accuracy. The accuracy might be different. So I need to check whether all these columns are required or not. And again I'm going back and finding only a 6 column. Then I'm finding accuracy of this one. Let's say initially the accuracy is going to be 65, sorry, 65 something, okay, 67 or 71 point some blah blah, and 75 some value, and tuck, 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 80.23 and 81.81 point something. So these are the accuracy like when I'm doing my okay. So these are the set of accuracy when I'm selecting my features. So first I'm selecting with all the list of item. By the time I'm getting some different frequency, sorry, some accuracy, and when I'm selecting only this column, this the accuracy might be differ. And at at last moment, let's say like if I'm going with 3 columns and 3 features, and the accuracy might be will go with like let's say it's 81.45. So I need to compare with this the analysis, because I'm selecting the features. This is nothing but features, right? The each column. So if I'm selecting the more features, and the accuracy might be less, and when I'm moving towards like reduce, keep on reducing my my futures, then automatically the accuracy will get increased. Okay, and you can ask me. So if you're reducing reducing the frequency, say futures, it may increasing the frequency. Is that a correct approach? Yeah, good question. But if we need to their consideration, so that's the reason we need to understand the correlation between the tables. You could remember that we have put on the plot called pair plot. In the pair plot itself, the system will indicating that whether the two variables are related each other or not. So initially we are doing some comparison of two different variables. Then finally we are declaring, okay, you are going with the two different variables. It's correlated. The meaningful future which needs to be included in your analysis. So if you're selecting the model from here, when you're selecting the future from 1, 2, 3, 4, 5, 6, and then you're finding your what is that? The target variable accuracy is one way of the process, and you can have first step F1, F2, F3, F4, F5, and F6. The again we have to do the we can we either we can go ahead with the backward method or forward method. So if we're increasing from cylinder into model or origin, then we need to figure out like what is the accuracy of the model. Then we need to find out in which forward model. Let's say this is your process 1, process 2, process 3. If I have the only one if I have only one frequency for only one feature for my analysis, that is going to be process 1. If I'm selecting the two feature for my analysis, let's say P2, and let's say P3, P4, P5, P6, P7. Honestly, this is not at all required, so we can stop over here. So we need to find out what is the accuracy level, and certain timeline you can find out the accuracy moving here and there. For example, I can have one more here. Chuma, just I'm putting, okay, for understanding purpose, I'm putting. What is this, man? Come on. Let's see. Okay. So here it may be a 76.32, and here it's going to be a 64.45. So if I'm moving forward from when I'm selecting this alone cylinder alone, it's a 64, let's say, and I'm selecting displacement and cylinder, this is 70. And like for example, when I'm selecting a 4 option, it's going to be after 67, 80, then it's become 676. Then after I'm selecting accelerated or model, after selecting the model, it's become 67. Then after I'm removing this, after I'm adding this one, removing the model and adding this origin, then it's going to be a 81. Means I can say yes, there is some deviation. There is no proper correlation between some variable. That's the reason here some deep depth is there. So here I'm reducing. Okay, here my accuracy is going down. So obviously I can exclude the specific future for my analysis permanently. So no need at all, not at all, no need to include my specific feature for any kind of analysis in even in the future. So that is nothing but your backward future extraction and forward future selection. Simple understanding if you're going back and forth. Okay. So don't confuse yourself. There's a conceptual ways, like I told you guys. So selection things, you know very well. Feature is equal to yesterday. I think you remember we did one. Okay, so small. If you want, I can pick up that. So I'll show that how we can represent in that. Yeah, update. Which one that? heuristics decision tree. Yeah. So it's a simple concept, guys. I'll tell you, like here when I show the coding, like you can change and you can apply, you can find the difference. That is nothing but straightforward future selection, like backward future selection and forward let's say since you guys are like electric electronics, right? So adding one more resistor in the circuit and removing one more resistor from the circuit, or seriously you are connecting resistors in the circuit and changing that into parallel, so that output voltage can be vary, right? So how we are manage that? So we want to get out the specific output voltage for the circuit means, so you can accordingly you need to design your circuit very similar to that. You can keep the your you can keep future one by one, removing one by one, so that it will be easy to analyze the model, and finally you can restrict with that. So why we are going in that mode? Because because if your model initially is going to be at least 1 2 3 4 5 6 7, so initially it was a 7 column. Because of the categorical variable into the numerical variable, it's become 200 column, means really unrealistic. We need to figure out whether all these columns are useful or not, right? So by using this methodology, you can identify. That is a very important thing. Random forest, already we know that. Forget about all the things are there. Okay. So everything all we cannot familiar with that. So random forest already we done. Just now I told it's a very simple way. In the coding, if I show that, you can catch that point. Okay. Just few minutes, it will come up. Yeah. Here initially I'm selecting. Okay, sir, not this one. Yeah. So here I'm selecting my future column, all these things. Okay. Selecting. So my accuracies might be different. So what I'm doing, I'm selecting, first of all, I'm selecting with pregnant, then I'm getting some value, and I'm adding my insulin feature, and then I'm getting different one. And then I'm the BMI I'm including BMI. Again, I'm getting different range and all things every. So until I'm keep on adding this column, the things will be different. Not going to be in production. That's very important. In the production, not at all required to keep on adding and what is that, inky pinky, right? So choosing the best one, something like that. So in doing that, designing your model, it's different. Okay, it's a different, but you can keep on changing that. The same way, backward reaction. Backward means like removing this pedigree, and then I can use this column, and after removing the BP, and I'm selecting. Okay, 1 minute, it's hanging here. Yeah, and I'm selecting glucose until the pregnant, and then again I'm doing selecting only this is a backward. So I'm moving from backward futures, and it's a forward few things. That's it, simple. Okay, so this is nothing but my random forest and sorry, not if backward things, and as well as my. Okay, so that's very important features which is available in dimension reduction. Okay, so the other things like there are so many options are available. Don't confuse yourself. So at this level, then it will be good for you guys. Don't confuse more on that. So let me open the scrap, and then we can close that session. Okay, so based on that, 1 minute. Oh, Lord, this one. Okay, so hope you understand like the concept behind that forward selection, backward selection, right? It's very simple. So once I uploaded my YouTube videos and all, probably I can share the link with ma'am so that you can go ahead and see that. So that, because actually going to make a 10 15 minutes video on that. So at a stretch, if you're taking everything, then really you'll get bored, and even we don't have enough time. So you may like be confused. So make sure that what are the things we have so far we studied. So just go through the slides and my notes. Even you can study some outside of that outside of the slides what I'm providing. So make a clear note, okay, and put a separate note and put all um, the concept what we have studied, and get ready for your interview. So if the interviewer asking something related to the data science, means probably if you started throwing fewer coins in sequence way, okay, like how to making the model here and there, just to tell them keywords. So definitely that will impress the interviewer. You got selected for as a data scientist, I'm sure on that. Okay. So because actually for the entry level trainee and all, like they won't expect not like research and all. So they'll expect at maximum level. So that is more than enough for you guys. Okay.